Well, this is a different way to do the operators conference for me anyway. I like the interaction. Thought we'd introduce ourselves real quick. My name is Brett Moore. I'm a senior engineer with Anderson, Perry and Associates, and I've got the expert helping me here.
I'm Kyle Willman. I run the wastewater treatment facility in Pendleton.
One of the things that Kyle and I were talking about a few weeks ago was how well their ORP monitor has been working for their chlorine pacing system at their treatment plant. And through the years, I noticed a lot of frustrations by different operators on getting some good chlorine analytics and getting good information that's consistent and reliable. So Deb had asked for ideas for operator conferences, and I thought, you know what, we need to share this information.
Yeah, this is a great thing. You know, just with the city of Pendleton, I think there's about 5 or 6 different chlorine monitoring systems that we've tested out over the years, and there's either a ton of maintenance or chemicals involved in the system, or they just weren't accurate. So, and then we've continually fallen back to the ORP probes. So.
Well, good. We have, as we go through here, we've got, this is kind of set up to be interactive, and we're not interactive. So,
well, you and I are interactive.
Yeah, we're interactive. So we'll see how this goes. And hopefully you guys will get some good information from it. It's definitely not a professional production, but we'll share what we've got pulled together here. So really the title is Chlorination Monitoring Using Oxygen Reduction Potential. We thought we just talk a little bit about historic chlorine residual monitoring. And some of you are probably familiar with different types, but and are probably using some on one level or another. Chlorine residual monitoring can be done with total or free chlorine. You have to be aware of what your test is set up for.
And what your permit limits allow you to test for.
There you go. So, and everybody's gonna be different because every permit is a little different. And so we just need to be aware of what you're doing there. There are different types of analyzers that are available. Some of those analyzers require a chemical reagent, and some of those don't. They have been problematic for many years. And I can just remember first project I was on in the early 90s, treatment plant in central Utah, and the lead operator was just cussing, trying to recalibrate his chlorine residual analyzers. They were pacing their disinfection with their contact chamber and just could not. They thought they'd have it all set up and they'd walk away and leave it alone and come back the next day and things were off, or come back the next week.
It's amazing how much water chemistry can affect that part of the analytics. Chlorine does weird things in different types of water. You pull from a different well, all of a sudden your whole chemistry changes in the plant. So that's one of the things we've seen with some of our tests.
Yeah.
Different times of the year, the water department will pull from different wells, which changes some compound, some chemical in the water, whether it be more manganese or what. And it completely changes the reactivity of the chlorine.
Yeah, for those water systems. I think another point with wastewater systems, and especially a lot of the people in our area, a lot of the operators, is pH. Some of these lagoon systems will experience algae blooms that will spike the pH, and then your effective chlorine drops, and basically your disinfection ability. And so being able to respond to those, and obviously that one doesn't happen immediately, but it does happen over a fairly short, within a week period. And so being able to know and understand what's going on in a real-time manner is very beneficial. Because of that, and all the time I get salesmen coming by or whatever that says, hey, we got the best analyzer, you know, you need to specify this one or that one. And when you dig into the issues with it, or you dig into how it really operates, there hasn't been a lot of change in the science behind them. They're still all pretty much the same.
Yeah, very much so. The key there, I think, really is, you know, make them put their money where their mouth is. Make them demo the analyzer. And that really right there, whether they're willing to demo it, tells you whether they're going to stand behind that product.
Yeah, pilot it for a couple weeks.
Yeah.
Let's make sure.
That's all it takes, really. I mean, most of the stuff that we've tried, within the first week, we have a pretty good idea how much work it's going to take to keep that analyzer within calibration specs and how much O&M requirements are required with it.
Right.
So.
Right. All those concerns that we're kind of talking about plays in a little bit to the negatives, but there is one positive with respect that we could identify with the analyzers. They do actually give you a result showing your chlorine concentration.
Yep.
So as long as you have the correct test, whether it's total or free chlorine, it will give you the limits that you need to compare with your permit with respect to chlorine toxicity for those discharging systems. So that is the positive there. So I was going to ask who monitored chlorine residual and how, and just do a little survey as we go through this. And so even though this is a recorded thing, if during this this playing of this presentation, if you guys could go to the chat box and then just identify for us which operators, which of your systems are analyzing chlorine residual, and if you're using free chlorine or total chlorine, and what kind of analyzers you're using.
You might describe the difference between those two, because I don't know if everybody knows the difference. I'm trying to remember. I just read that section in the new left book. The free chlorine. Oh man, I'm gonna mess this up. I know it.
And I try and interject, but I'd probably get it wrong too, because I believe I know what it is, but I might not be right on book with it.
Let's come back.
We'll come back to that, but I believe that free chlorine is the chlorine that's available for disinfection.
That sounds right.
When you have total chlorine, that's all the chlorine in the system. But we'll let Kyle get that. But if you could, in the chat system, let us know if you're monitoring chlorine residual, if you're using free chlorine or total chlorine, and then how you're doing that. Are you doing just test strips? Do you have what kind of analyzer? Are you doing real time? Are you doing some sort of reagent, some chemical that you put in there, and then it changes colors and et cetera, et cetera. But if you could explain a little bit how you're doing that, I think it'll give us a little better idea as we move forward into future short schools on what the needs are and what the systems are.
So the book definition, free chlorine involves the amount of chlorine that is able to sanitize contaminants, while combined chlorine refers to chlorine that has combined directly with contaminants. Total chlorine is the sum of both those things.
So basically it's the chlorine, free chlorine is the chlorine that's available to react and disinfect, where total is the chlorine that already has reacted and the chlorine that is available to react.
Yeah.
Okay. So.
Which is exactly what I was thinking, but I was second guessing myself.
All right. Well, we would appreciate your input on that. So go to the chat and let us know. Thanks. So what is oxygen reduction potential? It's referred to as ORP. And so for those of you who are falling asleep, this is one of the questions that you're going to have to answer to prove that you're paying attention. So oxygen reduction potential is the measurement of how oxidizing the water is. So an oxidizer like chlorine is used to disinfect the water by reacting with the cell walls of the bacteria and viruses to destroy them. So basically, it's not always just chlorine. Sometimes it can be hypochlorite, or sorry, not hypochlorite, can be H2O2, hydrogen peroxide.
Ozone does the same
ozone
thing.
does the same thing. And so, but if your disinfection system is chlorine, if that's what you're using, then the ORP measurement will be the oxidizer chlorine. And it's really what's available to oxidize. So it's going to be your residual determination. So as the amount of the oxidizing forms of chlorine reduces, your ORP measurement will also reduce, correct?
Yep.
Okay. So hopefully that's helpful.
And later in the presentation, we go into exactly how we set the city of Pendleton's disinfection system up. And actually, I'll be able to talk about actual numbers of where we run and how they affect each other. So,
And then also how your ORP number, how do you get your chlorine residual for your permit?
Yeah.
We'll talk about that. Okay. So how does an ORP sensor work? It's pretty straightforward. The ORP is measured by a probe and a sample of flowing water. So in the sensor, there's two electrodes. There's the ORP electrode and then a reference electrode. And then you have a signal that's sent between the two electrodes, and then that determines the oxygen reduction potential.
yeah, there's also a temperature probe in this because there's a correction for temperature. So the one nice thing about the Hawk ORP probes is you can pull temperature right out of the same sensor.
Right there.
Which is also an indicator when the probe goes bad, when the temperature sensor doesn't read right anymore. So kind of a little tattletale that we've learned over the 10 years we've been running this system.
Well, that's good. Chlorine pacing with ORP. So basically, a set point ORP is determined based on the desired amount of chlorine residual at the measuring location. So this is really, every plant's can be a little different.
Yes.
What do you really need at that location? So you'll be using some chlorine residual sampling and your new ORP probe to kind of set that up.
Yeah, we do residual testing every morning and every evening. We've been doing it so long now that it just kind of has become a staple. Whether we actually need to continue to do it that often, because permit requires us to do it daily. So, but we do it just to make sure that our ORP is correct. It's a safety net for us, basically.
Okay. On that basis, you get all the permit information that you need, but you're just trying to verify that your pacing
Yeah.
is correct.
So when we first started this system, prior to being ORP, it was all manual adjustments. And we were using somewhere between 60 and 70 pounds a day of chlorine. Now we run anywhere between 20 and 50 pounds, depending upon the time of year. Wintertime, colder temperatures, colder water, less sunlight, less chlorine needed. Summertime, more sunlight, hotter, water's warmer. We use closer to the 50 pounds a day.
So in the past, you were overdosing the chlorine to handle the variations through the day.
Yep.
So then you had to overdose your
Dechlor.
sulfur, your dechlor,
Yep.
to make sure that you were covering that. So your chemical cost savings on both ranges.
Yep.
So that's good. And so really with the ORP, this last bullet's important to know that you're dosing based on flow rates not normally used.
Nope.
it's all about ORP. And so as your flow increases, it'll automatically determine that my concentration in my chlorine is decreased. So I gotta up that.
Yeah, it's kind of an all-inclusive thing. The flow rate's not included in the calculation because the more water you flow through there, basically the faster the water's going by that probe, the probe's going to see that drop and dose more to adjust for that increased flow. So it's just it's kind of self-built in.
Okay. Excellent. So here's just a picture of Pendleton's Hawk systems with their ORP sensor. Let me see if I can move this out of the way because it's covering the probe here real quick.
I don't know if they'll see that.
Okay, maybe I was just seeing it.
Yeah.
So now you can kind of see the probe end. So on the left is just the digital displays for the 2 units. Well, you explain it. It's your system.
So yeah, when I got the email from you, I happened to be up at the aeration basin. So these are actually the ORP probes that are at the aeration basin, not in our contact chamber. Essentially, they're exactly the same. But what you see here on the left is a SC200 Hawk controller, which is what we use with our Hawk probes. They're universal controllers. So if you look at the screen, you can see that on the one on the left, very top, it looks like we got ORP, and then you got a temperature, and then below that, you got a solids concentration in that basin. And it's the same controller we use for ORP, for dissolved oxygen. So that's the reason we've gone with that controller, is because it's so universal. The operators love it because it's really intuitive for the menus for calibration for all the probes, no matter what. They're self-identifying, so when you plug a probe into it, it knows what probe you plugged into it, so that it loads that program off the probe to it. Okay. So the really nice, really easy use. And then on the right, you see the actual ORP probe out of the water. We've got them on, I think they're about 7-foot sticks that go down into the water. And then a little picture where you see me holding the adapter. We built those to protect the probes from when basically what we had is people were breaking. You can see on the very bottom, there's a little silver dot sticking out on the end of that probe, and that's a platinum tip. And what we had was, while people were calibrating, they were sticking the probes into the cal bottle, and they were actually breaking those tips off.
Okay.
So we built, and all it is
just a shoe.
It's a coupler. I think it was 1.5 inch or 1.25 inch coupler, and we basically cut, half of it out, but cut 2/4 out and left the other 2/4, and it protects the tip from being broke off. And we've never had another tip break since we've done that. And we'll go into that whole process of cleaning and calibration. So yeah,
So with your controllers, because you use the universal controller with the different sensor heads, do you have a spare one that you keep in case one of the controllers goes out?
Yep.
You just grab it, plug it in, and
yeah,
it works for everything.
You just mark where all the wires go, pull it out, put the new one in, wire it back in. We used to have the SC2 or 100s. They were discontinued and they've gone to this 200, which is in essence it's the same controller, just their new version.
All right. So I don't know what I did, but there we go.
This probe maintenance, this is essentially right out of our SOP at the plant for doing the maintenance. We do this once a week. Takes the operator about, I want to say it's like 45 minutes or so to do this from start to beginning because of the walk time, because it's one of the probes that's one in the contact chamber, and then the controller at the other end of the contact chamber. So there's some distance there to walk back and forth. But basically, you go to the probe, you take it, you pull it out of the water, you spray it down with a Liquid soap. It's basically just a really mild detergent. We use the Scotch-Brite sponges, where it's got the Scotch-Brite on one side, sponge on the other, and just kind of clean it up a little bit. You're not, like it says there in bold, you're not trying to scratch or scrub anything with the sponge. You're just trying to wipe off the film because it's wastewater.
Right.
There's a biofilm that's going to form on everything. And then we'll turn around and we'll soak it in that soap for 15 minutes. And usually you'll see, like, if you're looking at the controller, that ORP will, I think it goes down, if I remember right. So we set our chlorine dosing pumps in hand at that point, so that, you know, the controls don't take over and do really crazy things. So we'll take, before this, we'll look at what our dosing rate is, set it in hand at that, which bypasses the SCADA control systems. And then for that 45 minutes, we're basically in the hold.
It's holding the same.
Yeah.
So are you able to, just a question, when you do that and you put it in hand and you hold that same dosing rate, you can see what the ORP output is. Then when you put the probe in, you're able then to see what the probe is reading now to see if there's something weird, if you damaged it or.
Yeah,
what
so I'm
happened.
trying to remember exactly. Because our ORP at the chlorine contact chamber runs between 500 and 600 millivolts is what the reading is. It's in millivolts. So when you see up here, like on the other side, it says 6 or 200 cal solutions. At the aeration basin, we use a 200 cal solution because at the aeration basin, we operate those ORP probes closer to 200. And at the contact chamber, it operates closer to 600. So one of Hawk's things is you want to use the cal solution that's closest to your
Where you're
process.
Okay.
The other thing is we learned the hard way. These probes are about $2,400. It's a single point calibration. So you do not go from 600 to 200 solution one right after another, because that will poison the probe and actually cause the probe to go bad. We learned that the hard way. That cost us, I think, two probes when we realized what had happened.
So you're following the manufacturer's requirements on that.
Which we have changed for them. Yeah, we've actually had Hawk's customer supports on this has been above and beyond, and they've worked with us, and they have actually changed their manufacturer recommendations based on some of the things that we've experienced for them.
Yeah,
they're guinea pigs, I guess. So from the soaps, the soap soak, we go to a muriatic acid soak. It's 5 minutes, and that basically just takes any of the calcium deposits, any hard water, whatever, off that probe tip. Right after that, we go back to the soap, and then from there we run 2 different solutions for our probe cal solutions. And the reason for this is we buy the 1 gallon jugs. Can't use the 1 gallon jugs in the amount of time before it expires. So the first solution is always our expired stuff. And basically we change it out pretty often. And then the B solution is our not expired, good standard solution. So it spends 15 minutes in that solution. When you're looking at the controller, it should read 600. when it's in that solution. There shouldn't be, of course, the probes are plus or minus 50. So you should be, I've never had them.
550 to 650.
No, I mean, they're always usually within 20 of that, give or take. And then you just calibrate it, and the next week it's usually right in that same range. And we've gone through, so we replace our head ORP probe every year. And the head ORP probe goes to the middle ORP probe, and then the middle ORP probe goes up to the aeration basin. And that's how we keep the newest probe in the most critical spot in the process.
Okay. So through this discussion, Kyle gave you the answer to one of the other questions that they're going to ask you to make sure you're still paying attention. And that had to do with single point or double point calibration. So you want to explain that again?
So single point calibration, you only use one cal solution. Dual point or triple point calibrations, you use just like it sounds. You're either using 2 or 3.
So it's like, if it's your influent flow meter, a 2-point calibration is 0 and max.
Yep.
Right? And then it'll span between it. So in this situation, it's.
Or a pH probe, you're usually using 3. You're using, it's 4, 7, and 10 pH, the pH probe.
So again, is this single or double?
Single.
Just for everybody, single point calibration on this one. Okay. So if they get that answer wrong, they're not paying attention.
So here's just a picture of our basic setup for our buckets. On the left, you can see everything's in a 5-gallon bucket. Usually before the operators go out, they'll put about 6 inches of water in that bucket. 4 inches, 6 inches, something like that. Just enough water in there so they can rinse the probe with it. And then the next picture in the middle there is basically everything set out on the table. You can see it's labeled for 200 millivolt solutions. You got your AB, your muriatic acid, your soak, and then we operate you can see the sponge on top, our gloves, the twisty ties. So basically, I should have put a picture in here of that, but the probes, they'll sit in the 200 solution, and then we use those twisty tie to tie them to the handrail so they don't tip over, or, because the wind, it's Eastern Oregon, right? When does the wind not blow? When it's not convenient. And then we run 2 spray bottles. One's usually got distilled water or just tap water in it. And then the other one's got the soap solution in it for a quick wipe down. And then on the far left there, you've got the big bottles of the main solution that we use.
Far right.
Or far, yeah.
Their left, all right. Is that how it works?
Maybe. I don't know.
All right. So where do you get those chemicals? I'm assuming the ORPs. The ORPs, the 200 and 600 is manufacturer?
From Hawk. The liquid NOx, I believe, is from one of our lab companies. And I'd have to ask our lab lady exactly where she orders it from.
The muriatic you can get from just about anywhere.
Yeah, I think we pick it up at Zimmerman's here in Pendleton. They always have 2 or 3 cases in stock down there, but I think I've seen it at Walmart. One of those random things,
Yeah.
Not something you're normally looking for, and you happen to run across it.
All right. So this isn't really the probe. Well, let's go through this.
Yeah, so this is basically walking through the menu of the SC200.
On the controller.
On the controller, yeah. So, you're not running the Hawk setup. This is obviously going to be way different. So
let's go ahead and go through this just to show, how much work it may or may not be, and if we can screw it up or not.
Yeah. So basically, you go to the menu. push the arrow button down until you see sensor setup, push enter, the arrow down, you select the sensor. Like on our contact chamber, we've got 00, which is the head, and 01, which is middle. And you select which one you're going to be messing with. And then you arrow down to calibrate. And then you arrow down to 1-point manual, push enter. You arrow down until the hold box is highlighted.
And that's what you were talking about with holding the current dosing rate, right?
Yeah, so this tells, because I think the three options are hold, linear, and exponential or something like that. We always use hold, but before this, we always basically you got handoff auto on our pumps and put it to hand. And that way, nothing you do to this controller
will change
the
chlorine dosage.
Yeah, so.
But in this situation, you leave the chlorine dosing pump in auto, but you've changed this to where you're holding the dosing rate signal coming from the.
It's supposed to hold, like say it was reading 550. It's supposed to hold that number and send it out as that, no matter what you do from that point on, is what it's supposed to do. I'm kind of one of those guys where I like to have that extra level of comfort feeling, I guess. So I always go to the chlorine dosing pump and put it in hand
and make sure it's there.
And hold it there.
All righty. So you do that first bullet and get it held basically before you even start to clean the probe, before you pull the probe and work it over.
And then you walk out, like I said, it's like 300 feet from one end of our contact chamber to the other. You walk out there, you clean the probe. Then you walk back to the building. You go through the calibrate here, and the screen at this point should say move the sensor to the cal solution. And then you push continue, press enter. The screen, so basically it'll read, it almost looks like it's in the solution. So you'll see the numbers changing with the millivolt readings that it's seeing. And once that settles down and it stabilizes, it'll automatically go to the next screen, and this is where you actually adjust that number to 600. Like I said, most of the time you're seeing 580, 590 something, or 610. You're typically not seeing it very far off 600. And then you push enter, and you're done. You go out, you rinse the probe back off out of the cal solution, and you drop it back into the process.
Yeah.
And usually we come back in after that, and the screen says return probe to process, and then you push the home button, and you're back to the main screen.
There's a lot of bullets there, but it's actually really easy.
Yeah, I mean, that first bullet there, the main bullet, takes you about 3 seconds to go out and clean. You know, you're into the cleaning. I think it's like 20 minutes.
Most of that's soak time with the probe, right?
Yeah, so you're just standing there twiddling your thumbs, kind of waiting. A lot of our guys will like do some hosing in the influent launder, the contact chamber, do some stuff like that. I mean, it's a wastewater plant. Spiders are crazy all the time for some reason. And then you go out, you run through the calibration portion of it, and then you're basically done. Like I said, it's about 45 minutes with walk time and everything.
Yeah.
So this is where it gets into the programming. So we'll just start off at the top bullet there. The chlorine pump is dependent on the head ORP reading. So in the picture there, you see chlorine head ORP. The set point is what it's shooting for. So that's what it's shooting for. And on the left-hand side, the AIT CCC 00, be over a little bit further.
Right-hand side.
Right
over here.
There.
506.
So when I took this picture, the ORP probe is reading 506 and it's looking to hit 495.
The set point shown on the left column.
Yeah. We have an average function built into this to kind of dampen how quickly that thing moves. We've built in some damping abilities so that we have some human input to either make it slow down. Like last year when we were flooding, we wanted it to react a lot faster, so we almost removed that dampening out so that it would actually move more appropriately, because we went from 2 million gallons a day to 10 million gallons a day. So,
right.
So next bullet down, head ORP set point is dependent on middle ORP reading. So that set point is based off of what's happening in the middle ORP. So the very center box there is your middle ORP.
So is everybody going to have a head ORP and a middle ORP? Is that just for your plant? You've actually got two different probes that you're monitoring.
We do it. So the head ORP basically tells us that we've got chlorine entering the system. Middle ORP basically tells us that we're getting our disinfection time. So we're getting our contact time. So we want to see that we're putting enough chlorine into the system that we essentially, if I say this right, have some free chlorine by the time it hits the middle ORP. So that we're basically dosing enough that there is some extra
chlorine left.
Yeah.
And even when you do that, you're still seeing a chemical reduction by having the ORP pace your chlorine.
So with no chlorine going at all, our water at the contact chamber is right around 400 millivolts.
Okay.
So it's like for some reason 425 is like really sticking in my head. We don't see it. Like, we don't ever want to see it, let's be honest. But it has happened like once or twice.
So how does your chlorine pump, when you have the two sensors, which one is it really controlling? Your SCADA system decides it's got to meet both conditions?
So what it does is basically if it's not meeting the middle ORP set point, it adjusts the head ORP set point up, which in turn will make the chlorine pump turn up. So if you look down, you'll see a sample interval towards it's exactly the bottom one on the middle ORP. So that's the amount of time it takes to go from the head ORP to the middle ORP on an average flow. And then on the head ORP, from the point that we're injecting the chlorine to the point that ORP sees it I think it's actually 5 minutes, 45 seconds or something like that on an average flow day. So again, there's variances every wastewater plant. You see that flow, it goes up and down during days and nights. So we take the average, and that's what we use there. And then we've got some things in here like minimum speeds. We don't ever want to see our chlorine pump go below 20 for the speed on the chlorine pump.
Right.
Because we know based off our experience with our facility that below that becomes problematic with meeting our E. coli disinfection.
So I think it's important to note, the screenshot that we see here is the SCADA system.
Yep.
So this isn't the controller from the ORP manufacturer. This is the SCADA system, and this is programmed, set up specifically for your system, your treatment plant.
Yeah, and this is it's a Rockwell software, and we use a company there in Pendleton, Syntec Controls, to program all this stuff for us. Let's see what else we got here. Sample interval, dead bands. The dead band is basically how far we allow the probe to move above and below that set point
Before you try and make a correction.
Yeah. So we allow for it to have some movement. That way it isn't just constantly changing that set point over and over and over again.
So you have two things there. You have the dead band, but then you also have the dampening, which is the response time. So it's not going to try and move until it's at least 5 away. But then when it actually goes 10 away from the set point, it's not going to immediately jump up, and then your pump starts ramping up, ramping down, ramping up, ramping down.
So, and you can see on here, we also have our correction amount. So we've allowed it that plus or minus dead band. Like on the middle ORP, we have a 10 millivolt upper dead band. We have a 5 millivolt lower dead band. So basically, we don't give it the room to move below 500, but we've allowed it some freedom, twice the amount of freedom to move above that. And then the correction amount is basically how much, if it's, so let's say, actually this picture, it's right at the, let's see, 534 on 01, and it's looking for 500, and it's allowed 10 above. So based on this picture, it's actually going to turn the set point down at the head because it's actually overshooting in the middle.
But then your pump speed in the bottom right is at 23%, but your minimum pump speed is 20%. So it's approaching minimum anyway.
Yeah. So this was probably taken first thing in the morning when I came in. Yeah, this looks like a morning reading. This is what what it looks like on our screen when we click on it. You can see we've got our calcium thiosulfate, which is our dechlorination agent. The tank, you got your level there. You've got your pump speed. The chlorination is over on the very far left. You see we've got one chlorinator online. It's running at 23%, which is about 23 pounds a day. What that kind of equals out to with our setup, because what we've got going there. And then you can see the 2 ORP probes, and we've also pulled temperature out of those ORP probes to our SCADA system. And then you can see where we have had a chlorine residual. We've had about 6 different chlorine residual probes that we've attempted to use, and the remnants of that is that box right there.
Is that you have a minus 0.55 parts per million of chlorine?
Yeah, that's because it's just not hooked up.
And so basically the ORP is optimizing your chemical usage. And then you're able to, because you're optimizing your chlorine usage, you're able to pace your dechlor with that.
Yeah, so
chlorine.
Actually what we found out with our dechlor, the calcium thiosulfate, it's a food grade calcium thiosulfate.
So you just set it?
It has a shelf life. So it's set at 68 strokes per minute, because that runs it out in the shelf life period. And
okay.
So here's the trending graph of, and this is something that I look at daily. Every day I come in, and what I'm looking at here is the very bottom line. I guess I'll go from the bottom up. The very bottom line, one you can't even see it. It's a black line. That's our chlorine pump 2. It's reading 0 because it's off, which makes sense. It's, you're looking for things that are out of the ordinary. The next one up is the blue line. That's my chlorine pump that is online. And you can see the changes. I believe there's about 3 days that are on this graph. And you can see the 3 days are fairly similar. The overnight portion is the flat line in between.
At minimum.
Yep. Because our flows drop down to 1.815 million gallons overnight. So you hit the minimum. So you can, right there, you can see that the system flow places itself. The next blue line up, it's kind of a bluish purple. Military says I'm colorblind, so it looks blue to me. Is the middle ORP. You can kind of see how it trends kind of up and down. And that one, we always look to make sure that it's below the
head.
Yeah, which is a kind of a turquoise color. It's mixed in with the green, which is our average function.
So basically, the difference between those is basically their chlorine demand between the two.
Yep.
So it looks like you've inverted a little bit on the right side, but generally speaking, it's.
Yeah, and you can see at the very bottom, and the reason that happened is we ran at minimum
For a long
for
time.
a very long time.
So you're
So
overdosed.
basically, we had some really low flows coming into the plant, and we overdosed.
So that was the end of the slideshow. I just wanted to reiterate a couple things. And this is why I think it's important or beneficial. The use of an ORP probe has allowed the city of Pendleton to basically pace their disinfection to optimize their chemical usage. And optimizing the chemical usage for the chlorine, you're able to reduce your dechlor demands. And so there's some significant cost savings there. And it's more reliable than what we found on the market anyway for chlorine residual analyzers.
Yeah,
for flow pacing, basically the automatic analyzers.
The ORP probes, I mean, you're doing some weekly maintenance on them, but chlorine monitoring is such a heavily permitted item that you can't afford not to do that maintenance on any chlorine monitoring system. So,
but it hasn't gotten rid of your need to do chlorine residual testing. You still have to do that, but that's more on a lab basis as opposed to an analyzer that you're trying to flow pace with, or you're trying to pace.
Yeah, so we test right before it leaves the contact chamber to make sure that there's, we usually end up with 0.1, I think it's ppm, right before it leaves, before dechlor, and then after dechlor, like 0.002 most of the time ppm, which is way below our permit limit.
Right. Okay. Hopefully this has provided some information and gives some food for thought, not just for wastewater systems, which is an example that we're using here, but also for those water systems that need to flow pace with their chlorine system. And they can use that, especially some of the surface water communities out there.
Yeah, from my understanding, the reason this works so much better for wastewater is because our residuals are not required to be as high as the water system. Yeah. I mean, anybody that's watching this class that wants to come and do a tour of the plant to see exactly how this all works, walk through the entire system, more than welcome to show up and go through the facility, or give us a call at the plant and walk you through it.
Sounds great. Well, we hope this is worth your time, and we gave you the answers to 2 questions. I don't remember what the 3rd question was, so you'll have to watch the whole thing.
Yeah.
All right. Thanks.